Hi everyone, this is Mr. West. We're doing another Khan Academy today on volume, word problems, fractions, and decimals. Khan loves volume, and that's good enough for me. It's a very relevant topic, especially for geometry. So let's go ahead and get down to it. Ben bought the enormous box of juice shown below, right here. He drinks 450 cubic centimeters of juice each day. Odd that he knows it that specifically, but let's go ahead and roll with it. So we have 450 cubic centimeters of box of juice each day. Now, if it's saying cubic centimeters, that means this is referring to a volume. Okay, so we know that that is the volume of what he drinks. How many days does it take Ben to drink the box of juice? Okay, wow. So it's enormous. I guess it is. 20 centimeters is pretty big. That's like almost a foot tall. So we have this box of juice. We should probably calculate the volume of this box. The volume of a rectangular prism, which is what this is area of the base times the height. Now, the area of the base is the same as length times width. Okay, here's your length, here's your width. So generally with rectangular prisms, you're just multiplying the dimensions of the box altogether. So the dimensions of the box are going to be 15 times 10.5. Okay, 15 times 10.5. And then the height is, we'll call it 20. Times 20. So we just need to get our little calculator out here. We get 20 times 10.5 times 15. And this is easy enough. We get volume equals 3,150. Okay, now this is the total volume, cubic centimeters of this box, but he drinks, was it 450 a day? Okay, so what we're going to do is we are going to divide by the number of the volume of what he's capable of drinking per day, and this will tell us how many days equals question mark days. Okay, so once we do this, we're going to find out exactly how many days it's going to take him. Okay, and once we do this, we get 7 days. So it takes him 7 days when we divide 3150 divided by 450. That's what he can do in a day. So it's going to take him a week to drink this juice box, and I hope he keeps it refrigerated. All right, next question. The YMCA lap pool is a right rectangular prism, 36.8 meters long by 20 meters wide. The pool contains that much water. How deep is the pool? Okay, cool problem. We're going to use blue because it's a pool. So we know that it's 36.8 meters long and it's 20 meters wide. This is not to scale. Okay, this is our pool, and then we know it goes underwater like this. Okay, something like this. I can't see the... Okay, you can't see it either. Okay, so we're good. Oops, I want this to be underwater. Crud. I'm being a little nitpicky here. I like drawing, so I want it to look ugly. Okay, so we don't know how deep, we'll call this D, is the pool. But we know that the total volume equals 1472 meters cubed. We already know that's a rectangular prism, so that means it's length times width times height. So we know that we can substitute a few things here. We can substitute this for our length, we can substitute this for our width, and we can substitute this for our volume. So let's go ahead and show what that looks like. That's actually a really cool arrow. I wanted to use the other one, but I like it. 1472 equals 36.8. Okay, my pencil, there we go. Times 20 times our height, which we don't know. That's what we're looking for. I'm going to highlight it so you know that we're looking for. We're looking for that. Okay, what we're going to do here is we're just going to solve for h. So I'm going to do 36.8 times 20 first. When I do this, I get 736 times h equals 1472. 1472 times, or divided by, I don't know why I said times. Okay, so I divide by 736, divided by 736, and I get that the height of the pool is 2 meters deep. That's pretty standard, about 6 feet. Okay, there we go. Bruce bought the enormous box of juice. Are you kidding me? That's the best they can come up with. All right, so this is like the first one. So this guy's going to drink that much juice per day, and we want to know how long it takes him. Okay, so I think, are these dimensions the same? 30 by 10.5 by 20? Are those the same ones we had? I can't remember. And I'm not going to look back, so if you guys can comment and let me know if I actually did the box. No, it's not. I don't recognize this number. 6,300, I don't recognize that. So if you commented, thanks, but not necessary. So 10.5 times 20 times 30. That's the volume of the juice box. And then how much does he do per day? 630. Okay, another oddly specific dude. We're going to divide by 630. Oh, this one's easy. So once we do that, we're just going to essentially cancel out those, and we're going to be left with 10. So 10 days it takes them to drink this enormous box of juice. Christian put a large rock on the bottom of the terrarium, he made for his pet turtle. The rock is a right rectangular prism. Yeah, okay. So it's a brick, is what you're telling me. 10 centimeters by 12. The rock displaces that much water. How high is the rock? Well, if you measured the brick, why is he not measuring how high the rock is? Whatever. Okay, so we got a brick here. I don't care if they call it a rock. It's a brick. And it's 10 by 12. So I didn't really draw this correctly. Sorry, I'm being a little nitpicky here. There. It's a big old rock, okay? Brick. It's a brick. So here's our brick, and it's 10 by 12, okay? 10 by 12, and we want to know how height of this brick is, knowing that the volume is 1,800. Okay, so 1,800 is going to be equal to our length times width times height, of which we know our length and width is going to be 12 and 10. So we have 1,800 equals 120 times h. We're going to divide by 120. So 1,800 divided by 120. That gives us a height of 15. Height equals 15. So it's actually pretty tall, 15 centimeters. Check it. And there we go. So that's all there is to it. Hope you guys enjoyed this video. Wait for the sound. Wait for the sound. There it is. If you guys need more help with anything, please leave a comment. I'll be sure to help you with it. And I really look forward to seeing you next time right here on this channel, Wes Explains Best. Thanks for watching.